are you today? Most likely today is the same as yesterday was. It's just come and gone. With all of your daily, typical problems, whether it be family, relationships, school, or work, the big picture has probably become invisible. My friends, we're in a crisis. In a global economy largely dependent on energy, the unfortunate reality is that this energy is quickly being expended. As time progresses, this reality is developing into a crisis, a clearer depiction indicating that current methods for attaining energy are not sustainable. A search for a viable alternative continues. The dilemma of the situation occurs in that the Earth's resources are finite, while civilization's demand for fuel sources are ever increasing. In fact, the average growth rate of consumption of fossil fuels is found to be about 1.5% per year. As you can see in the diagram, the prospective year for the complete exhaustion of fuel is about 70 years from now. While this might seem far enough away to not be an immediate issue, as one source is dissipated, the rates of exhaustion for the remaining fossil fuels increase, as seen in the slopes in the diagram. Biodiesel is a viable alternative source of energy the world should consider in its pursuit to phase out petroleum from the current energy matrix.
The most popular method of producing biodiesel in industry today is through a process called transesterification. A flowchart of the scientific process of transesterification in a plant that manufactures biodiesel might look a little something like this. Here, the initial step of this flowchart involves feeding excess methanol with oil in the presence of a catalyst to a reactor. The products from this reactor are esters, glycerol, the leftover methanol from the feed stream, and a soap byproduct. The product stream then splits into two different compositions at the separator. 50% of the bottom stream's composition is glycerol. The remainder of the stream has some of the excess methanol, most of the catalyst, and most of the soap. From there, the bottom stream takes majority of the undesired product and converts them into viable materials that can be recycled or sold. The top stream contains the desired esters, most of the excess methanol, and some trace amounts of soap and catalyst. This stream is fed to a methanol removal step. This step had to come after the glycerol was removed, since the products would revert back to the original reactants, since the reaction is reversible. The next step is put in place to deal with the soap and catalyst present in the mix, the neutralization and washing step. Here we put acid in the mix to neutralize the residual catalyst and also break up the soap to form water-soluble salts and free fatty acids. This step is crucial since soaps give the mix a high viscous characteristic, a very unfavorable aspect to biodiesel. Next, we wash the mixture to free the stream of salts previously created and other undesired components. The resulting stream is primarily composed of esters and free fatty acids that are fed to a dryer to become the finished biodiesel product. A large factor that was not previously mentioned is where the oil comes from for the feed into the transesterification process. The oil used for this biodiesel producing process can come from a large spectrum of sources. We will focus on two specific source categories, animal and plant. Mark and Shane will discuss these points further.
Many different plant oils can be used as sources for biodiesel feedstock. Generally, the crop is pressed and heated slightly in order to extract the oil. Some crops contain more oil than others, making them more viable for further processing into fuel. Some North American crops that fit this criteria are soybeans, rapeseed, also known as canola, and hemp. Certain criteria such as oil percentage, viscosity, and flash point can be used to compare these sources. As far as oil percentage, canola oil has the highest percentage with 36 to 50% oil by mass. Biodiesel produced from hemp oil has the lowest viscosity at 3.48 millimeters squared per second at 40 degrees Celsius. Flash point is a little more interesting, as the ASTM specifications for 100% biodiesel fuel specifies that you have to have over 130 degrees Celsius flash point. So generally you want a higher flash point, but if the flash point is too high, it can contribute to engine knock. So because of this, hemp oil biodiesel provides the best flash point at 162 degrees Celsius.
Using animal fat as a source for biodiesel production is a promising possibility. Waste animal fat is typically discarded, so utilizing it in the production of biodiesel is an efficient alternative to just throwing it away. The fat needs to go through a rendering process in order to extract the oil and rid it of pathogens and impurities. This process consists of grinding the animal byproduct to a fine consistency and cooking them until the liquid fat separates and pathogens are destroyed. Cooking the waste fat removes water, which makes the fat and solid material stable against rancidity. The amount of oil extracted depends on the type of animal fat used and its purity. Pure fat compositions result in greater oil conversions compared to residual compositions. Due to the fact that animal fats are highly saturated, biodiesel made from them have a high cloud point, which can lead to clogged fuel filters and engine injectors in cold climates. However, these effects can be mitigated if the biodiesel is blended with standard petrodiesel. Not all fats are the same, though. Upon comparing the percent conversion of 3 widely available animal fats, beef tallow, mutton, and pork lard, into biodiesel using potassium hydroxide as a catalyst, one can see that pork lard has the highest conversion percentage at 98%, while beef and mutton fall behind at 95 and 79% respectively. The other determining factor into which is the better source for biodiesel is how easily accessible these sources are, which is solely dependent on where one lives. For example, beef and pork are the U.S.'s top animal products, while India produces virtually no beef. Taking this into consideration, it seems that pork lard is the best animal source for biodiesel production, but the availability in each country can make other animal fat sources more realistic options.
Evidently, both plant and animal sources possess certain qualities which make them the more desirable source. Since fats are currently simply dumped in landfills, producing biodiesel from animal fats qualifies as an efficient method of altering what is now waste into fuel. Plants exhibit greater possibility as a universal source of energy. With their lower viscosities and cloud points, plant oil sources of biodiesel are more reliable in variable climates since they are less likely to solidify. The feasibility of plants as a geographically ubiquitous source make it a favored source over animal fats. When looking at biodiesel as a possible fuel in the future, as with any science in the developmental stage, further research must be done to maximize effectiveness and efficiency of both the method of production itself and also the engines which are using the fuel. With the exhaustion of fossil fuels gradually drowning an energy-dependent society, biodiesel emerges as a potential alternative, but more importantly, as an option to simply keep us afloat.